Welcome to this video. Today we are going to learn how to solve both exponential and logarithmic equations. We're going to start with exponential equations. And there are a series of steps we're going to take to solve these equations. We're going to isolate the exponential expression. The exponential expression will be the base and its exponent. We're then going to write in log form, so we will transform our exponential equation to log form, and then we're going to solve for the variable. So in the first example, solve e to the x minus 2 equals 70. I'm going to isolate, step one, I'm going to isolate the exponential expression. So that's e to the x. So to get that on a side all by itself, I need to add 2 to both sides, giving me e to the x equals 72. Now I'm going to write that exponential equation in log form. So this is log base e of 72 equals x. And we know that log base e is the same thing as the natural log. Notice how I'm writing the argument in parentheses. I will tend to do that just to be clear on what the argument is. So we have the natural log of 72 equals x. That is called an exact answer. That is an exact answer. An approximate answer, we would need to put that into our calculators. So we would grab out our calculators and we would put the natural log of 72 into our calculator, and you can press pause and try this and make sure that you're going to get the same answer that I'm going to write down. The approximate answer from the calculator, rounded to 3 decimal places, is 4.277. 4.277. So there's 2 forms of the same answer. Okay, let's try another. We've got 4 times e to the 2x equals 5. We are going to isolate the exponential expression, the base raised to its exponent. So right now the base raised to its exponent is being multiplied by 4. So I'm going to undo that multiply by 4. I have to divide both sides by 4. And we get e to the 2x equals 5/4. Now we're going to write this in log form. Log base e of 5/4 equals 2x. This may be a different way of solving for some of you, but this is a really good tool to have, so I'm going to continue to show you this process. Log base e is the same thing as the natural log. So I've got the natural log of 5/4 equals 2x, but we want 1x. So I'm going to have to divide both sides by 2. And our exact answer, I'm going to use my space over here, is x equals, you can say the natural log of 5/4. 5/4 is the argument, all divided by 2. Or it might be a little cleaner to say 1/2 times the natural log of 5/4. And then after using the properties that we've learned previously, some of you might say, can I take that 1/2 and bring it to the argument? You could do that, but it's not typical that we do that. This is an exact answer. And our approximate answer, I encourage you to press pause, put this in your calculator, and make sure you get the same value I get. 1/2 times the natural log of 5/4 is approximately 0.112. Good. Okay, here's 2 for you to try. I encourage you to press pause. Try these 2 on your own. You can try one and then press play, and then press pause, and then try the second one. But it's important that you try these on your own and make sure that you've got it. Okay, welcome back. This one on the left, e to the x equals 55. that gives us log base e of 55 equals x. So x equals the natural log of 55, which is approximately 4.007. If you got that answer, you're probably feeling really good and confident moving on to the second try. The second try is going to be a little bit more challenging, but give it a shot. Okay, welcome back. I started by writing log base 2 of 5 equals 3x plus 1. Log base 2 of 5 is just a value between 2 and 3, a little bit closer to 2. So this is just a decimal. This value is just a decimal, 2 point something, 2.2-ish. This right here is just a decimal. So now we're back at algebra 1. We've got something like 2.2 equals 3x plus 1. Don't let the logarithm confuse you. This log base 2 of 5 is just some number. I'm going to subtract 1 from both sides so that I can solve for x, and then I'm going to divide both sides by 3. And I get x equals log base 2 of 5 minus 1, all divided by 3. You can also write that 1/3 times log base 2 of 5 minus 1. And I did not put that in my calculator, but if I did put it into my calculator, I would probably have about 1.2 divided by 3. I'm going to quickly put that into my calculator. Probably hear me getting up and taking the calculator out. So I just used my change of base formula and found that log base 2 of 5 is actually 2.3-ish. So 2.3-ish minus 1 gives me this value right here. So this value right here is about 1.32. And when I take that and I multiply it by 1/3 or divide by 3, I get approximately, x is approximately 0.441. I'm going to box this answer. However, I do like the 1/3. I do like this form of the answer. That's a good form. So just make sure you know how to write both forms of the exact answer. Okay, in the next video, we're going to, actually, let's continue. Let's continue doing all of our exponentials. This is a good one because it's a quadratic in nature. So you can see that the first exponent is twice the second. So this is a great quadratic in nature type of problem. This is factorable. So this is going to factor into two binomials, and we'll be able to use our zero product property. So how do we get back to e to the 2x? That's e to the 1x. So e to the x times e to the x is e to the 2x. For those of you that are saying, huh? Same base, repeat on the base, add the exponents. X plus x is 2x. So e to the x times e to the x is indeed e to the 2x. And then we have to multiply to get back to positive 2. And I need both signs to be negative, so -1 and -2. That outer gives me -2 e to the x. The inner is -1 e to the x, which is -3 e to the x. I'm going to use the zero product property, set each variable factor equal to 0 because my equation is equal to 0. So we have e to the x minus 1 equals 0 and e to the x minus 2 equals 0. E to the x equals 1. That I can do without a calculator. X has to equal 0. This second one, e to the x equals 2. So I've got log base e, which is the natural log, of 2 equals x. So my two answers here are x equals 0 and the natural log of 2. Those are exact answers. Now it says check your answers or solve both algebraically and graphically. Graphically, we would need to put this into our calculator. So I would put the original trinomial into my calculator under y1. So I would have y1 equals e raised to the 2x minus 3e to the x plus 2. Now I will encourage you to press pause and put that into your calculator so that when I draw that graph on my screen here, you can confirm that you got the same answer or the same graph. So you should have gotten a graph that looks kind of cool. It looks something like that. And then if we're going to solve, we're going to need to find the roots. So when we find those roots and we ask the calculator to solve, it comes back with approximately, actually equals 0, but approximately 0.693. And if you were to put this into your calculator as the natural log of 2, you would get 0.693. Okay, here's one for you to try, both algebraically and graphically. Both algebraically and graphically. Go ahead and press pause, and then I will reveal the answer along with the work. Okay, welcome back. The work is e to the x minus 2 times e to the x minus 3 equals 0. E to the x equals 2, e to the x equals 3. So we have the natural log of 2 is equal to x, and the natural log of 3 is equal to x. So x equals two values, the natural log of 2 and the natural log of 3. Those are exact answers. I do have faith that you can put this into your calculator. And you should have gotten an x-intercept a little bit past 1 and a little bit past 1/2. And this one comes around like this, and it does something like that. So we get x is approximately 0.693, which is this equivalent to natural log of 2, of course rounded, and 1.099. So there are our answers in two different forms. So we have two answers, natural log of 2 and natural log of 3. The blue highlight is the exact answer, and the orange highlight is the approximate answer. Okay, in the next video, we're going to continue to solve a few more exponential equations and go into some logarithmic equations.